Now, if we want to figure out what are the design goals for the MyChip system, the example that we have, now these are the analysis models that we have so far. Now, we can have a look, and perhaps a good starting point is the non-function requirements. Some of the non-functional requirements would map directly to design goals, so that's something that a good starting point. Now think about it for a moment and see if you can figure out what could be design goals based on the models that we have so far. Here are some examples. So there are things that can be directly mapped from number 2 here. Once the chip has been started, my chip should give correct directions, even if modem fails to maintain a connection with the planning service. So if the internet is not available, okay, so if the internet is down, but after the system has started, should be able to use the planning service. Like I should be able to use the planned trip even if the modem is down. That's actually if you use Apple Maps or Google Maps, sometimes they provide this kind of service. If you download the route early on, even if the connection fails while you are on the trip, it doesn't it would continue working. Okay, so it doesn't disconnect or it doesn't fail when the internet disconnects. Okay, so from there's reliability. Okay, and there is also fault tolerance. Okay, there is a problem there, but the system was able to isolate the problem and still continue working. Now, some requirements doesn't have to be directly listed in the requirements. I mean, some design goals doesn't have to be directly listed in the requirements. You can derive them from the application domain, like the security. Obviously, nobody wants a hacker to attack your uh, map or your trip system. And modifiability, that's something a developer might want to have. Like it is anticipated that there would be a change in the future, which it should be the requirement, like a design goal for every system now, because we already know in the software development requirement change often, so we want to be able to modify how it works. So modifiability would be one of the design goals as well. So these are just examples. And as I mentioned earlier, everything is subjective. Okay, there's just suggestions there, and you would be able to make a good judgment with experience. Now let's see how are we going to define system subsystems. We talked about that a little bit, but we didn't provide a criteria. There is no specific standard criteria. It's all heuristics. Now, when we talk about dividing the system into a subsystem, we just talked about either using the style design patterns or the styles, or just whatever is logically related. Okay, so we're gonna use some of these heuristics to begin with. You can just try any attempt, logical grouping, or there's another heuristic that we're gonna mention right now. But this is just the initial cut. This is the first attempt, and then the subsequent attempt might involve merging existing subsystems or actually splitting complex subsystems. Okay, so let's see. Identifying the subsystems of the MyChip. So these are the design models again. Now, one heuristic is to create a one subsystem per use case. Okay, this is the initial design, the initial decomposition. It's not, it doesn't have to be perfect. It will never be perfect the first time. So let's start with something. One way to start with is to create one subsystem per use case. Okay, so you would have the routing subsystem and planning subsystem. And then all the classes or the entities that are related to the routing would go here. and the classes or the entities related to the planning would go there. Now, there are some classes that are not exactly clear where they should go. Okay, so these set of classes can go here or can go there. So what should we do with them? Now, a decision needs to be made here. Okay, so these classes are shared, so they are used in both. They would be used in both use cases, so they could very much be in either. Okay. Now, they are tightly coupled to each other, so there is high dependence between these classes. They should go together, so it's not a good idea to split them because they are tightly coupled. So we need one decision to put them together. Okay, but where should we put them, here or should we put them there? Now, let's see if we put them in a separate subsystem by themselves, since they are tightly coupled. How is that going to affect the coupling and the cohesion? If we put them in the routing subsystem, how is that going to affect the coupling and the cohesion? If we put them in the planning subsystem, how is that going to affect the coupling and the cohesion? Now, if we put them in a separate system, there will be 3 dependencies. You see this 1, 2, 3 on them. So the general count of the dependencies would be high. There will be less dependencies, subsystem dependencies, if we put them in the routing subsystem. And it would be even less if we put them in the planning subsystem. So if we want to prioritize the coupling, then we should put them in the planning subsystem. But if we want to prioritize the cohesion, we should put them in a separate subsystem. So which one is more important for you? Now that's a decision you have to make. An example decision is to prioritize the coupling. So if we prioritize the coupling, we put them here. If we prioritize the cohesion, we should put them in a separate system. Now that's a decision here. The example decision that was made is to prioritize the coupling. Okay. So it's put them in the planning subsystem here, would have only one dependency between the two subsystems. It's just one example.